The notes in this video are going to discuss the differences between perfect squares and square roots and what you need to know about them. The first thing we need to do, though, is define what each one is and look at some examples of each one. A perfect square is not necessarily the shape. We're talking about individual numbers and whether they qualify or not. But by definition, a perfect square is a number that has a rational number as its square root. Right? And just to help you understand what it is, since it's using both words to define each word, this is also made by multiplying a rational number by itself. So to put this in a better perspective, I'm going to give you some examples of some different types of numbers that are still classified as perfect squares based on the definition that you were just given. Right? Some of them are going to look a little odd to you because you're not used to thinking about them this way, but they still qualify. And now we need to start thinking of them as what they really are. Right? So this next group is just a list of examples for you to use and to verify. Right? The number 9 is a perfect square, right? Because it is made by the value of 3 times 3. So the number 3 times itself makes the 9, right? Or the value of 9 can also be made by doing -3 times -3, right? So it qualifies when both positive and negative versions of the same number are multiplied times themselves. And that answer that you get is what is known as a perfect square. Right, so if I do another one, if I take the number 196, right, that is made by 14 times 14. Or if you want to look at the counterpart to it, 196 can be made by -14 times -14, because a negative times a negative makes a positive. Right, so they both are legitimate ways to approach and get that same number of 196. Okay. The next part, though, is something that you're not used to seeing, and that's fractions and decimals, right? They can also still be considered perfect squares as long as it's being multiplied by itself, right? So if I have the fraction 16 over 25, okay, that can be made by multiplying 4/5 times 4/5, or -4/5 times -4/5 even, right? But as long as you know that a fraction times itself, the answer to it is still considered a perfect square. Right? Likewise with decimals, if I have the decimal 6.25, okay, that decimal is made by multiplying 2.5 times itself. So as long as the same number is being multiplied times itself, the answer will qualify as a perfect square. Right? Now on the flip side of things, if it's not a perfect square, right, then its other counterpart, or its opposite, is known as the square root. And the square root has its own symbol, right? And its own symbol has its name too. Right? We don't always call it by its name, but it does have its own name. Right? The symbol tends to look like a check mark with a bridge across the top. Right? And I know you've all seen them before. Right? That symbol actually is called a radical sign. So it does have its own terminology to go with it. Right? But we typically just say the square root symbol. Okay. And by definition, square root is the inverse. You'll get used to seeing that word this year, which is also a synonym for the word opposite. So it is the opposite of squaring a number. When you square a number, you raise it to a power of 2, or you multiply the same number times itself. Right? So the square root is the opposite of that. Right? So once again, I'm going to give you some examples, and I'm going to use the same numbers that were previously mentioned above, but show them to you in a different light. Right? So those perfect squares that we were dealing with above, if I take the square root of 9, I get the answer of 3, because remember that 3 times 3 is what made that 9 in the first place. So we're kind of going backwards and unraveling it this time. If I have the square root of 196, right, the answer that was multiplied times itself to make 196 was 14 times 14. So the square root of 196 is just 14. And if I go with the fractions and decimal examples that I used, you can do the same thing. If I take the square root of 16 over 25, then it was 4/5 times 4/5, so the square root of 16 over 25 is just going to be the number 4/5. Right? And if I take the square root of 6.25, then the answer is going to be 2.5, because that was the number that made it. Okay, so you can see that these things are related to each other and that they have a type of pattern that's going on. Right? The one thing you're going to have to be able to do in 8th grade this year is to deal with and estimate and predict between what number certain square roots are going to fall. So the directions you're going to see quite a bit of on the questions that you're going to be responsible for are going to say this: between which two consecutive whole numbers does the number lie? Right, so they're asking you either through a number line situation or just in general, between what two whole numbers will that square root answer fall between. So I'm going to show you this and introduce you to it by means of examples. There's nothing really to give you step-by-step instructions on, but I am going to show you through picture mode and example mode. All right, so the first one that I'm going to show you, if we have the square root of 11. Now, first of all, we need to help understand what those directions are asking. The word consecutive might be new for some of you, right? So if you haven't come across this word or don't remember what it means, the word consecutive means back to back. That means no gaps in between it. Right? So on a number line, 2 and 3 would be back to back. They'd be consecutive. There's nothing in between them. Right? But if I said 2 to 4, that's not consecutive because 3's in between them. So it has to be one number right next to each other on the number line. All right, so back to my example of the square root of 11. If you type in the calculator 11 and then hit the square root button, then it's going to pop up with this long decimal that says 3.3166 blah, blah, blah. Right? You don't need to worry about the rest of the numbers. Typically the first 2 or 3 after the decimal is all you need. Right? So if I'm looking at this decimal, right, then that's not telling me between what two numbers it falls, but that gives me a good idea of where to start. The number that's in the front of the decimal, that first number, it's going to be the first number in your answer. So when I'm trying to figure out where's this decimal going to fall on my number line, it's going to fall between the numbers 3 and then on a number line, the number that comes right after 3 is 4. So the answer to this problem is 3 and 4. Okay, now if they ask you to plot the square root of 11 on a number line, because you may see it written this way and that's all they want to know is 3 and 4, or they may ask you to place a dot on a number line where the square root of 11 would be, well then you would still use that same decimal and you would have a number line that has a couple of numbers on it so that you can plot some things. And we know that the numbers between the 3 and the 4, and because the number after the decimal is a 3, it's going to be closer to the 3 than the 4. It's not quite halfway, so don't put it halfway. So we're looking at roughly right here. So you put a dot where it's approximately going to be, and you label that dot whatever number it is. So that's where the square root of 11 would fall on an actual picture of a number line. All right, so let's take a look at another example of this to make sure you're getting the hang of it and that you understand what you're doing. All right, for the next one, the directions are still the same. All right, this time though we're going to use the square root of 80. And the square root of 80 when you type it in the calculator is going to give you about 8.944 ... Okay, there's no need to worry about the rest of the numbers. Right? And again, that number right in front of the decimal is your starting number. So the answer to this problem, if you don't have to graph it, is just going to be 8 and then on the number line, the number that comes right after 8 is 9. Right? So it's 8 and 9. It has nothing to do with the 9 after the decimal. That's just coincidental. It's what comes after 8 on the number line. Right? Then if you were going to graph this one, you know you need the 8 and the 9 at least. 8.9 is very close to 9, but not quite exactly. So get close to 9, put your dot, and label that square root of 80. So you can see about where it's going to fall on that number line. Okay, we're going to do one more of these, and then we'll switch to another skill that you'll have to be able to do. And then this topic will be finished. All right, the square root of 152 is now what we're going to talk about, finding the two consecutive whole numbers it falls between. So when you type it in the calculator, you end up with 12.328 ... Okay, and if you notice, the first number is a 12. So that means in our answer, it's going to be 12 and then right after 12 on a number line is the number 13. Right, so it's 12 and 13. Now, if I want to graph it, I know I need the numbers 12 and 13 on my number line. And because it's 12.3, it's going to be closer to the 12 than it will be the 13. So about right here would be the square root of 152. Right, so graphing it is a possibility, as well as just giving the actual answer. Right, and then the last part of the skill that you'll need to know for this topic, right, is to round each square root to the 10th place. So this will focus on your rounding skills and help you fine-tune those or just reinforce them if you already remember them. Okay. And before we go any further with the examples on this, there's a little trick to help you remember. Some of you might have little sayings from elementary school that you have, and you feel free to share those with me in class. I'm always looking for new and crazy ways to remember things, so if you got one, please feel free to share with me. All right, but the way that you want to know about rounding is that it's 5 or more, you round up. 4 or fewer stays the same. So if you use that trick, then rounding should never be an issue for you. All right, so we're going to do a couple of these just to get you refreshed on it and make sure that you really understand what you're doing. All right, so if I have the square root of 18, you are going to have to go to the calculator and get the approximate decimal value. That would be 4.242 ... In terms of rounding, the 10th place is the first number right after the decimal. So this would be your 10th place. Right? I want to keep a number in that spot, but the number after the 10th place, the hundredths value, is going to help me decide if I need to round up or stay the same. So if I look to the number right behind the 2, which is a 4, that 4, right, is 4 or fewer. So I'm going to keep my number the same. So the answer to this is going to be about, that's what that little squiggly part means, 4.2. Okay, so there was no need to change anything because it was 4 or fewer behind that first number. All right, so if I look at another one, if I have the square root of 319 in your calculator, that approximates to the decimal of 17.860 ... Okay, again, the 8 is in the 10th place, but in order to decide what I need to do with it, I need to look at the number right behind it, which is a 6. 6 is 5 or more, so that means I have to round that 8 up. So when I round it up, it doesn't stay an 8 anymore, it turns into a 9. So square root of 319 is the value 17.9. And the last example under this section, which will conclude our notes for today, is square root of 42. Type it in the calculator, you're going to get about 6.480 ... And the 4 is in the 10th place, right? But we need to look behind the 4 to determine what to do with the 4, right? Because there's an 8 behind the 4, that means I'm going to round up. So the approximate value of the square root of 42 is 6.5. Okay, and all that does is help you in terms of placing numbers on a number line and determining where they're closest to, right? Because these decimals do go on for a while.